Okay, sorry about that. My camera cut off for a second. So I want to go back and look at this problem again. All right. What I want to do is I'd like to make a change to the problem. Please cross off this and put 9x squared minus 1 over 3x squared minus 3. All right, this is going to be a more realistic example of what you can see on the test. I want to factor the top part. Okay, so I got 9, I got negative 1, I'm sorry, 9, 0, then negative 1. All right, so that's going to be 3x plus 1, 3x minus 1. Okay, the bottom one, okay, 3, negative 8, negative 3. Okay, I want to solve that one. All right, so that's going to be x minus 3 and 3x plus 1. Okay, now as you can see, okay, I can cross off these. Okay, so what I would have, if you look at this example, I'd have a hole at negative 1/3, because that's the solution for that. All right, so the idea is if that's we would go, it's really x plus 1/3, x equals negative 1/3. Okay, that's how you get that. Okay, now what I have left over, okay, what I have left over is I have 3x minus 1 over x minus 3. Okay, so what I'm going to do is I'm going to graph that in the calculator to get some of my stuff here. All right, I'm going to put parentheses around the top part and parentheses around the bottom part. All right, I graph. All right, g solve root. Okay, so I have one at 0.3 comma 0. Okay, my x-intercept's at 0.3 comma 0. All right, and then g solve y-intercept. Okay, sort of convenient. That's 0 comma 0.3. Okay, all right, so a lot of stuff there. Now, here's what you have to know. If you're doing a graph here, okay, I got to figure out the anchor point. Now, to do that, when I have a variable of a variable, it's a little bit different. Sort of I cover this up. Now this coordinate is still going to be the same, all right, like it was the other one, it's opposite of what's underneath. Now to get the y coordinate, when I have this, what I end up doing is I'm going to divide, okay, those numbers right here in front of x. Well, 3 divided by 3 is 3, okay. I've got a vertical asymptote at x equals 3. I've got a horizontal asymptote at y equals 3, okay. Now, all right. As x approaches negative infinity, y approaches blank, x approaches now don't be confused by this. This answer is always whatever this is. Okay? So it's 3 and 3. So we're always off the y coordinate there. So it's always off the y coordinate. Okay? Even though they're the same there, don't be confused. It's always off the y coordinate. Let's go to this next example. Okay? Alright, it says the graph of a function has a vertical at x equals 6, a hole at negative 5, and a horizontal at y equals negative 8, as x approaches infinity. So, just like that, that's going to be y approaches negative 8. Don't overcomplicate that. Okay? Find the range. Hint, use the calculator. Alright, so what I should do, alright, I'm going to graph this, alright, x squared minus 9 divided by x squared minus 25. Okay, now, here's what they want you to do on that. It's sort of a crazy looking graph. Alright, what you want to do is g solve max, okay, and just write that down for a second. That's 0.36, okay, and then g solve min, let's zoom out, okay, g solve max, okay, we got that, alright. And then draw g-solve minimum. Okay, we don't have one, all right? So the idea here, all right, is that if you looked at the graph, it's there, okay? All right, so what was the range, all right? So the range, all right, for a problem like that, let's go back and look at that one more time. I'll draw. Okay, all right, so the idea here is the graph is above, all right, the graph is below 0.36, all right, it is above 0.36, so this is going to be all real numbers, except for y can't equal, I'm sorry, y is going to be less than 0.36, and y is going to be greater than 0, okay? The reason why it's like that, sorry, greater than 1, okay? And the reason why it's greater than 1 is basically this asymptote, it's approaching 1, because I'm going to divide 1 divided by 1, okay, so it's above that. It's also going to be less than 0.36, because that's the maximum. It's sort of a different type of example, okay? So 1 divided by 1 gave me this part, okay? So if you look at the graph, it's going above. It's also going below with that U shape. All right, find the domain. Here's the idea of the domain. The domain is going to be all real numbers, okay? Except, all right, x can equal all my restrictions. So 1 and negative 3 over 2. Whatever's in the denominator, okay? Whatever's in the denominator is basically, you can't equal those numbers, those solutions, all right? That's it on that page. Okay, all right, so one of the biggest tricks in this, when they start giving you the graph, is to make sure that you draw the asymptotes in there, all right? So basically, if you look at this is like approaching this, okay? And this is approaching this line right here. So that anchor point is at negative 2, negative 3. Okay, that's one of the big things you want to figure out, because your vertical asymptote is x equals negative 3, and your horizontal, I'm sorry, x equals negative 2, and then y equals negative 3. All right? The domain. All right, since they're in diagonals, all right, the domain is going to be all real numbers, but x can't equal negative 2. The range, y is an element of all real numbers such that y can't equal negative 3. Okay, it's good for all those. All right, increasing, decreasing. All right, if you wanted to, basically when the graph looks like that, if you were to trace it, that's decrease, decrease. So it's decreasing the whole way. All right, this is none. All right, once again, to answer these questions, whatever this is, that's going to be your answer. All right, for both of those. All right, write two different equations that could represent the graph from above. Okay, let me give you an idea. Since my anchor point is negative 2, negative 3, all right, one example, all right, that's a great example right there. Opposite follow. Another example, okay, I got x plus 2 on the bottom. Let's say I have an x up top. Well, how can I get this to be negative 3? We'll put it like a negative 3 in front of that, all right, and that would also give you that same example. All right, moving on to number 12, okay? All right, once again, need to draw your asymptotes in here, okay? This one's going to go through negative 4, and I would say it's going to level off at about 1. So my anchor point there is negative 4, 1. Okay, that helps us with our vertical and our horizontal, okay? This zeros are at negative 5, 0, and negative 3, 0. The y one's at 0, looks like about 1. Okay, whoops, I'm sorry. That's not right, put that in the wrong place. Negative 5, 0, negative 3, 0, about 0, 1, about that, it's close. Okay, so the domain's going to be all real numbers, except x can't equal negative 4. Now, since the graph is below the asymptote, that's going to be all real numbers where y is less than 1. Okay, because everything falls below 1. Increasing, decreasing, all right? So from negative infinity, basically to negative 4, it's decreasing, and from negative 4 to infinity, it's increasing. Okay, decrease, increase. Okay. Once again, how do you answer this? Whatever this coordinate is, 1 and 1. All right. I think I'm moving on to 13. Okay. Factor. You got to factor both of those. Okay. From a cube standpoint, all right. You take the cube root of both of those. That's going to be x minus 4. Okay, you can use either the pattern, okay, or you can use the boxes or a combination of both. All right, so this is going to be x squared. This has to be 16. Okay, all right. If you want to follow the pattern, that times that would be negative 4x. That's got to be positive 4x. Okay, if you want to work through this, you know that that's got to be negative. These have to cancel out, and that's how you got that, negative 16x. And positive 16x. So if you want to use all the boxes or some of them and understand the pattern, whatever way is going to help you get it. So I got x squared plus 4x plus 16, okay, times x minus 4. All right, the bottom one, if you use equal for that, then you equal polynomial minus 4's cross out. So I'm left with x squared plus 4x plus 16 over x plus 4. All right, there's your answer for that. Okay, subtraction problem. So what you want to do is reduce, okay? Now, there's a little trick with that if you remember. I take a negative, all right, I make that y, and I do that minus 4. So what you do with this is you switch signs and order, okay? So that went from positive 4 to negative 4. It went from first to last. Negative y to positive y. Now, what I do is I treat this like a mirror. What's this side missing that this side has? Missing a negative 1. So what I would do is I'd multiply that by negative 1. So that's going to be negative y. All right, minus 3 all over the common denominator. I can't combine that. So what I'm going to have is negative 1 y minus 4. Okay? All right, very simply there. All right. This next one is a little bit more detailed. Okay? What you should do is handle this almost as if they're separate problems. So what I'm going to start out doing, okay, I got 2x plus 1. All right, it's got a 1 underneath it. I'm going to work with this first. This means a 2x plus 1, 2x plus 1. All right, I have to treat that negative 1 like a minus 1 like a negative 1. So what I got is I got 2x minus 1 all over my common denominator. Now what ends up happening there is that combines. So I got negative 1 over, okay, all right, basically 2x plus 1. All right, so that's that part of it. Then I'm going to handle this other part. 1 over 1 minus 2x over 2x minus 1. Okay, all right, once again, I need this to be 2x minus 1, 2x minus 1. All right, if I multiply that, all right, I get 2x minus 1 minus 2x over 2x minus 1. If I combine those, all right, what I'm left with, all right, is negative 1 over 2x minus 1. All right, so negative 1 over 2x minus 1. All right, now what's going to happen here? Division. This is just a fancy symbol for division. So that's going to flip. So what I got is negative 1, 2x plus 1 times 2x minus 1 over negative 1. Now the nice part about this is basically you can divide the negative 1s which cancel. So what's going to end up being my answer is 2x minus 1 over 2x plus 1. Okay? All right. The negative 1, that basically becomes a positive number. All right. Sort of complicated. What you want to do is split that into two problems. Division. Remember, in division, you flip that second fraction. That's got to turn over. That's why it went from here to here. There's nothing alike here. That's not the same factor as that one, so I can't cross those off. Negative 1 divided by negative 1 basically is a positive 1. All right? Let's move in down here. Okay? I'm going to work each one of these. So what I want to do is I want to use equal. All right, so I'm going to do 3. All right, 17 and 6. I'm sorry, negative 6. So that's going to factor 3x minus 1 and x plus 6. So I got 3x minus 1 and x plus 6. All right. Now, with this one, since it's backwards, I got to put a negative 1. Now, what that's going to turn into is just x squared minus 36. Okay? Key thing is a lot of people leave out that negative 1 there. All right? So I got 1, 0, negative 36. All right? So I got x plus 6, x minus 6. All right? Once again, since I have division, that means I'm going to flip these around. So when I do equal for that first one, negative 9, 18. All right, I got x minus 6, x plus 6, or x minus 6, x minus 3. Okay, now, what I want to do, since it's division, is that's going to go down here. Okay, all right, that's going to go down here because, all right, I want to make sure that I flip that second function. All right, go back and do the other one, 2. All right, negative 1, negative 15. All right, that's going to be x minus 3 and 2x plus 5. Okay, so now that I've done that, you always want to flip that second function. Okay, that's why that one went like that. I want to see what I can cross off. I can cross off these. Okay, nothing vertical here, nothing this way. All right, I can cross off this. Okay, so what I got left over up top is I got 3x minus 1, 2x plus 5, got a negative 1. Okay, I got x minus 6, x minus 6. Now, you're just going to write that as x minus 6, x minus 6. All right? Okay, I think that's it. Yep. Okay. All right, so make sure you write that like that. You just use all those ones over there. All right. 17, write the simplified expression. Nice thing is everything's factored already. So I cross off that. Okay. Anything else vertical? Nope, I can cross off that. Okay, and I can cross off that. So the simplified expression, 3x minus 5 over 4x minus 7. Now the restrictions, this is pretty easy, is anything from the denominator. All right, so I got x can't equal negative 6, x can't equal negative 2, x can't equal 7 over 4, and x can't equal negative 5. They're the solutions of the factors in the denominator. All right, pretty simple. All right, scrolling down. Okay, here's another addition subtraction problem. Got to make sure I reduce first, okay, or factor first. All right, so I got 1, 0, negative 49. All right, so that's going to be x plus 7, x minus 7. Now, this side here is missing an x minus 7. All right, now, what you have to do here is you have to use the boxes because you're going to multiply both of those. Okay? So that's going to be x squared minus 7x plus 6x minus 1. So on this side, I'm going to have x squared minus 1x, okay? Minus 42, not minus 1. Minus 42, all right, plus 4 all over the common denominator. Now, what's going to combine there? This and this. All right, there was nothing I had to multiply on that side. So what I got is x squared minus 1x minus 38. My common denominator is x plus 7, x minus 7. Once again, if you look over in your multiple choice area, the things that end up being used are this, okay, that one and that one. All right, okay. I believe this is the last problem. Yep, here we go. All right, so we're going to go to this last problem here. All right, I got to reduce both of these. 1, 0, negative 1. Okay, y plus 1, y minus 1. Okay, this one, the only thing I can do is I can take out 3. What that's going to leave me is that. Now, when I look at both sides, this side is just missing a 3. So I'm going to multiply top and bottom by 3. Now, this side's missing a y plus 1. So I'm going to multiply by top and bottom. Now, 3 times y is 3y. I treat this like a negative 5. So that's negative 5y minus 5 over my common denominator. What ends up combining is that. So what I got is negative 2y minus 5 over 3, y plus 1, and y minus 1. Okay? I think that's it. Yep. Okay? So what you have to be careful of now, what they did here is they took out a negative 1 to get that answer. All right? So there's a couple techniques. You got to make sure that you can reduce everything. Anytime something's backwards, like 3 minus x, you got to take out a negative 1 and switch it. Okay? All right? Make sure you understand the difference between multiplication, addition, and subtraction. Okay? All right, addition and subtraction, you have to get a common denominator. With multiplication and division, okay, like problems like this, you got to just reduce, flip, and eliminate. Okay? Make sure you practice it. This kind of stuff just takes some drill, and you should do very well.